Okay, now we're done with part 1. Okay, now we're going to go on to the part 2 where we're going to use the kinetic particle theory to describe the states of matter. So now, firstly, let's look at solid. Solid, we talk about their arrangement first. Okay, so the first thing we will talk about the arrangement of these different particles. Solid is regularly arranged and they have very little spacing the particles. So you can see here the spacing is very little. Okay, sometimes, let's just say this drawing here, try not to draw it. We draw the other one where we show the layers of particles. Okay, you can see from the way I'm drawing it now, it seems even more closely packed where the spacing is really very little. Okay, so when it comes to exam, please make sure you draw it in this manner. Okay, where the particles are really very, very closely packed. I mean, more tidily than this. Okay, now I'm just drawing it very quickly so that we don't waste too much time. But just take note, try not to draw a diagram that looks like this. Try to draw it this way. Now, okay, we talk about them regularly arranged. They have very little spacing between the particles. For liquid, you can see that there's no real regular arrangement. It's what we call regularly arranged. Irregularly arranged with very little spacing. Okay, not say with very, sorry, with little spacing. You can see that they are still very close. Okay, they are still close together, but the spacing is not as much as not as little as compared to the solid. And the last one we have the gas, which is irregularly arranged also, and they have very big spacing. Sometimes we tend to swap this. We will say all very close particles are very close together. Particles very close together. This one we say the particles are close together. And then the last one we say the particles are far apart. Okay, far apart. So sometimes we talk about arrangement, we tend to say okay, we will tend to use particles are very close together rather than we talk about the spacing. But both of them are actually similar. Okay, similar. Rather than arrangement, okay, other than arrangement, what else can we talk about? We talk about the movement of the particles in the different states. For solid, it's vibrating at fixed position. So think of all these tiny particles, okay, all these particles over here, okay, all these particles, they're actually vibrating at their fixed position. Okay, so they're actually hitting each other, they're vibrating over there. Okay, for liquid, okay, these particles, they're actually moving around. Okay, they are moving around, sliding over one another. Whereas for gas, okay, when I talk about gas here, the particles, they are moving around rapidly in any direction. Okay, sometimes we'll say moving in all direction very quickly or very fast, or moving very fast in all direction. Okay, the thing is that it must have the in any direction this kind of description, saying that it's a random movement. Okay, the other one is talking about rapidly, okay, or you can say very fast. This is the second thing you're talking about. So it's moving very fast in random direction. So you can see for solid, liquid, and gas, their movements are also different. One is vibrating about fixed position, one is sliding over one another. The last one, they're moving rapidly in all directions. And the last one, we talk about the force of attraction. Now think about it. For solid here, why are they so closely packed? There must be a force that's pulling them together. So what's the force that's pulling them together? Okay, we call this the force of attraction, and it must be very strong. Whereas for liquid, the force of attraction is actually strong, but not as strong as the solid. Okay, that's why we can see here, one we put very strong, one we just put strong. So you can see the force of attraction is actually quite strong, that's why they are still close together. And the last one for gas, they have very weak force of attraction. That's why they are very far apart. Okay, they are not very close together. So this is how we use the KPT to describe, okay, the various states of matter. In terms of three different things here, we talk about the arrangement. Okay, that was the first thing we talk about. We talk about the movement. And the third one, we talk about the force of attraction. Okay, so these are the three things that we talk about using KPT to describe our solid, liquid, and gas, the three different states of matter.